All right, everyone. Hello. My name is Dalia and I'm from Elastic's community team. And today we're here to hear from Erdem, who's going to talk to us about personalized music content as search implementation. Always take so it's easier for me on the chat. If you wish to ask them in English, it will be easier for me to help Erdem with the questions. If you wish to ask them in Turkish, then he will have to answer them himself. Thank you all for being here. And if you wish to speak, maybe please feel free to let me know. You can always email meetups@elastic.co. You can find more information on our website through Erdem as well. He can share his experience with you, but it will be great if you want to share your story as well. So without further ado, I'm going to give it to you, Erdem, and good luck.
Thank you very much, Dalia. Thanks for letting this happen, first of all. Hello, everyone. My name is Erdem Günay. I'm speaking from Istanbul, Turkey. I'm working at Turkcell as a principal software architect. And I'm also one of the organizers of Istanbul Spring Meetup group, where we organize regularly meetups on Spring framework related things, mainly the experiences that we gain from our real life projects, real life applications, and we share what we have gained in terms of technical details or in terms of experiences. And this is basically, this session is one of them because we have just recently replaced our music platform's search infrastructure from a Solr-based solution to a new Elasticsearch-based solution. And today I'm gonna try to share what I have gained, what I have learned throughout this rollout project. And I want to share with you some important points that I think I find important to me, so that maybe one of you, few of you, or you guys also get something and use it in your own real projects. So today's agenda is quite short, actually. I wanted to keep it as simple as possible so that the main points can be understood easily. Today's agenda is I'm gonna go over Elasticsearch analyzers, because this is the first things first, you know. First of all, we should be able to find all of our content, all of our documents, which is indexed in our search engine. If we cannot find it, if our users cannot find it, it doesn't make sense. The rest doesn't make sense. There is nothing that you can score based on ranking or other stuff. In the second part, I'm gonna go over ranking-based scoring, like if it makes sense to return popular songs, popular artists to the users with a trending approach. And then finally, I'm gonna mention how we did the personalization based on user behavior, how we managed to return personalized search results based on what our users have listened to, have followed actually. This link is pointing to my GitHub repository, which is Gunayus, my GitHub repository address, Gunayus, and Elastic workshop. You can follow everything later from this GitHub repository that I'm gonna mention today. This repository includes the Java project, and this repository includes the documentation of the steps and also the Kibana console requests. Let me begin with the analyzers. As I said before, analyzers are the key points in all the full text search engines, because if you cannot let your users find the documents that you indexed, the rest doesn't make any sense. The users should be able to find anything they are looking for. So the key part in Elasticsearch here is analyzers. When I started this project, I first had a look at app search, which is an out-of-the-box application from Elastic. I definitely advise you to go and look at it because it provides out-of-the-box features where I learned a lot. I learned almost all the analyzer details from App Search. So special thanks to this team as well. What we are going to do now is I'm going to index some documents. I'm going to try to find them, but I will not be able to find them with the out-of-the-box standard analyzer. So I should do something in order to be able to find the documents with these prefixes. So I will be mentioning character filters, token filters, and then continue. Let's begin with the Kibana part. In my sessions, in my workshops, I prefer not to do too much presentation, but more go into details with hands-on coding, hands-on details. Kibana provides us a very useful DevTools console here. You can interact with Elasticsearch very easily. You don't need to prepare all the details. It has a very good, powerful code completion features as well. Let me quickly look at my current indices. There are previous indices created in my previous trials. What I'm gonna do, I'm gonna delete everything. I'm gonna start from scratch. I'm deleting my listen event indices. I'm gonna delete my main content in this. I'm gonna delete user profile in this as well. And then I will keep artist ranking indices because I did some effort yesterday. I want to show you how a trending search results can be obtained from these daily indices. So I'm gonna keep it. I'm gonna show you at the end what makes sense with the trending search approach. What I will do, I will index a couple of documents with these IDs, okay, unique IDs, A1, A2, A3, A4, artist IDs with 4 artist names. All have a word, all have a token starting with S letter, as can be seen here. I haven't done any specific configuration, anything. I just indexed 4 documents with the standard analyzers. Let me see if I can bring them back with the ID. Yes, this is the first artist's ID. And I can also search them all without providing any criteria. So I can see them. That's good. We have the documents indexed in Elasticsearch. But let's play with it now. What about searching with out of these documents? If I try to search with prefixes, if I'm gonna be able to get the results. As I said, Kibana DevTools is very handy in terms of code completion. I'll do like this. You see, it completes the index names. It completes the operations, possible operations. I will do search. And then as I type, it will autocomplete that I'm gonna write the query here. My query will be a multi-match query. Immediately it will tell me the query string, which is gonna be S, I'm gonna try. And then the field names. Which fields do I want to search on with the given query string? Here it completes also the field names, which is quite handy. I'm gonna look for artist names. Let's try if we are gonna be able to find anything. No luck, we cannot find anything because Elasticsearch does not by default create tokens from your text fields with this approach. What about like this? If I try with the whole terms in the documents, if I'm gonna be able to find, yes, I can find with the whole words. Let's try Shakira. Yes, we can, but with one letter missing, I cannot find it. Here comes the fuzziness feature, which is quite a useful feature, which helps, but should not be exaggerated. It should not be used heavily because it may end up in bad situations, like you get lots of irrelevant results. I just keep fuzziness 1 in this search. I try again. Now I can find Shakira. But if I remove one more letter, I'm not going to be able to find it, because one letter correction is not enough to find Shakira. If I make fuzziness 2, I can find it again. So this is mainly fuzziness. Let me disable fuzziness. I'll show you one more feature. If I look for Cezanne and Gomez, you see the name of the first artist and the surname of the second artist. I can find both of them, which might look good in the first place, but I don't find it a good feature, because if I'm looking for Cezanne Gomez, I should be able to find something like Cezanne Gomez, not Sezen Aksu, not Selena Gomez. So what we do here, basically, we use the operator field of multi-search. If I make it or, it's doing the out of the box behavior, default behavior, or, but I want an and here, because I don't want to find all the documents including Cezanne or Gomez. If I want to find Sezen Aksu, I need to just type both Sezen Aksu together. These are the main things that we have used in our project: the operator, multi-match, fuzziness, and the fields. You may want to promote, you can provide multiple fields here. You can like request Elasticsearch to look for these query strings in different fields. For example, artist ID as well. I can like do searches with this. If I provide an artist ID here, I'm gonna get Shakira, because it finds the query string from this field. You can provide, with this syntax, you can provide different boosting factors to different fields. This is also a very handy feature, because you may want to promote special fields. If the user input search keyword matches with a special field, you might want to return those documents above the others. So what I do here, I'm basically increasing the score of this document because it hit from the artist ID. But if I look for Cezanne, the score will be 1 point something, because it didn't hit from this field. These are the main features that I want to show. So how do we fix this S problem? How can I find the documents with the prefix? Because I want to provide my users a feature like as they type, I want them to search like S, SE, SEZ, blah, blah, as the user types, I want to search the documents. So I need to do something. In order to find what we should do, we need to investigate analyzers. This command is very handy. You just provide your text and see what Elasticsearch would do, how it would index your documents. If you do not provide any special custom filters, character filters, what it will do, it will just lowercase the strings, the terms. Here, pay attention to this term, and this is the output token provided by the standard analyzer. All it does is just lowercase all the letters. It doesn't remove special characters here in the within the alphanumeric characters. It doesn't remove dot, it doesn't remove apostrophe, but it removes these characters because they don't contain any alphanumeric character. This is the default behavior. But what I want to do is I want to be able to find the documents with the first letter, first and second letter. So what I need is a custom analyzer. Here is one custom analyzer. Let's first delete this part and see the effect one by one, okay? I'm gonna use a standard tokenizer, but I'm gonna provide a character filter, which means that remove all the characters which is not alphanumeric and white space. So I'm expecting this dot, this apostrophe, and all of these characters gone. Let's see. Yes, it's doesn't include apostrophe anymore. Sample is just sample now with the dots removed. This is what the character filter does. It takes each character one by one and then applies the pattern. There are different types, of course, types of character filters, but I'm not going to go into details. If you apply this pattern, you get some of the noisy things cleaned out. Let me put back the uh, uh, filters. All right. First of all, let's do this lowercase. First of all. Okay. Filter means a set of collection of token filters. Once the character filters are executed, how to handle the tokens. Lowercase is just lowercase, lowercasing. Let's see the effect of ASCII folding. Okay, ASCII folding is very useful because it's difficult for your users to find these special accented characters, right? So it's better to remove them, actually, to make them ASCII folded. ASCII folding does it, and the final, we still cannot, you see, we still cannot find these tokens with only S or the first two letters. We need to do one more thing, which is edge engram token filter. What it does, it takes these words and separates them as the group of character sequences. You will see immediately. Now we have a lot of many more tokens. You see, we have H, HE, HEL until Helen, and similarly Segar. Okay, so this is what we need basically. What I'm doing, I'm going to delete the content index because that didn't include proper settings. Here I'm going to create my index manually first. And I'm going to provide some settings with the analyzers, including filters and etc. So what I will do, I will run this command and I will have my index created without any documents rate yet. Please pay attention to this field. Normally, artist name would be indexed just as a text, as a string, but I don't want it to be just as a string. I want it to also include special fields, like here, prefix. Prefix field should be generated from the artist names that I provide in the documents, but it should use I prefix analyzer and Q prefix search analyzers, so that before indexing the document, it will apply all these rules, all these filters, etc. And then it will store the documents like that. Now let's re-index the documents again, all four in the documents. I index them again, and now let's give it a try. Let's make the fuzziness 0. I don't want fuzziness. I want to look for artist name dot prefix. And yeah, I'm gonna find 4 documents because all of them have tokens starting with S, including this one. The second term starts with S, and I will find it. If I keep searching with the second letter, some of them are gone. Shakira is gone. If I continue with Selena, the others will be gone. So this is basically how you manage to index your documents properly. Let me see if I want to say anything in the ranking-based boosting. Here, the approach is, in the ranking-based boosting approach is managing the events that are happening in your application, in your system, because currently, right now, many people are listening to many different songs, many different artists. So if I collect this information, if I collect these events and make them meaningful to me, I can use these events for achieving better search results, for achieving trending search results. Like today, a new artist, one of artists may make a new song, and then suddenly it becomes popular, trending. My system should be able to react to this change, should be able to promote this specific song in the one of the top positions, so that my users can find them easily and listen to these songs more. So what we are going to do, we are going to maintain artist rankings based on listening events. Okay, and then we are going to build algorithm search criterias based on these rankings. The more an artist is listened, the higher score it should get, etc. Here, the points that need to be paid attention are these indices, these temporary indices, listen event indices. Should they be managed hourly, daily, weekly? It's up to you. You can make hourly, which results in an at most a 1 hour delay trending search results, which is not a bad thing actually. And also artist rankings could be populated, managed daily or weekly. So you can go back in the history, in time, you can go back 1 week, and then you can decide which artists were more popular in the last week, or in the last 10 days, last 1 month. You can make use of this information. So in order to do that, we need a couple of things. First of all, I'm gonna create 2 index templates, which is very handy because I'm not gonna every time create indices manually. Every minute in my demo, it's to make things simple. Every minute, I'm gonna create a new index with the events, and then every day, I'm gonna keep artist rankings indices. So using these templates are very handy to make sure that these fields are managed by Elasticsearch according to these definitions. Okay, listen event template, and then artist ranking template. Now we should go to our Java project. I'm gonna go quick. This is a Spring Boot application. Spring Boot is very easy, very handy. What you need to put in the Spring Boot application to make it Elasticsearch capable is these dependencies. We will use Elasticsearch REST high-level client, but with this version, with this specific version. So I need to exclude something. I need to include Elasticsearch low-level client, sniffer, etc. Okay, you can find all these things in the GitHub repository. If you get any questions, if you have any questions, you can always ask me, by the way. What I will do, I will send these events. Assume that these events are generated every time a user listens to a song from an artist, okay? So my scenario will be a user listening to artist 1, okay? This is 1 listening. You can see that this event is indexed in this index with a specific hour and minute. Okay, let me simulate that this user is listening to this artist a couple of times. Let's go back to Kibana and see if we really have them. If we really have these events. You see with the timestamp, I can see that an index with this timestamp is created and the documents are indexed. So what makes sense here is to have these events processed every minute for the sake of demo, but you can, as I said, you can make it every hour, every day, every week, whatever you want. Here I have a special scheduler which runs with an interval. What it will do, it will update artist rankings. What it will do, it will query the event indexes and aggregate the results for the artist with the artist IDs. Okay, it's easier to see it here. Where is it? Yeah, here it is. From these listen events, if I run such a query, with matching all the documents because I don't want to filter anything, but aggregate all these documents with this name, artists, but on the field artist ID. This gives me very, uh, very good summary of all the events that I sent so far. So this means that artist one is listened to 5 times. Okay, so let's do a couple of more. Let's send a couple of more events. Let's work on artist two. All right. Okay. I don't know, maybe more than 10. I need to wait a little bit because these events are indexed in 1930 index, but they will be processed at 1931. Okay, because I need to wait for 1 minute. In the meantime, while waiting for it, I'm gonna show you the other index. I'm gonna show you the artist ranking index because artist rankings are also populated real time. Let's see, artist ranking, all of them, because I have one ranking index from yesterday and the other one from today. Artist ranking will search, all right. Let's query with match all without any filters. So here you can see the artist rankings from the day before, 13th of May, 14th of May, and yesterday and today with this notation. Artist one is listened 8 times yesterday. Today, artist one is listened 6 times, and artist two is listened 17 times. So we can use this information for producing trending search results. All right. So let's try to see the output. In my Java project, I have a REST controller, REST endpoint searching for artists, but with some special parameters, arguments. I want to do ranking search first. I want to exclude the user profile based search for now. What I want to do, I want to search for artists with their ranking values with the query parameter S. Here you can see that since Selena Gomez is listened 14 times, it is placed on top in the first place because Sezen Aksu has 5 ranking. Shakira does not even have a ranking yet. So what I will do for the sake of demo, I'm gonna send some events for Shakira. I'm gonna promote Shakira, make her popular, and then see that at the end of this 1 minute, if I will be able to have Shakira already trending in my search results. Let's see, 1933. Okay, let's see what happens. Here, we should see the event index processed and the summary of the information is put into relevant indices. One minute. Okay, it's finished. It has processed the 1933 index, and let's see if it helped. If we are going to be able to see Shakira here. As you can see, Shakira is already trending in our search results. All right, I have 10 more minutes left before the questions Q&A session. I want to show you also the third feature, which is user profile based boosting. In the second part, which is very similar, very related to the second part, because it is also related with the artist rankings. But here we also put a new dimension, another dimension, which is user. I want to be able to show results based on the user performing the search request. In order to achieve that, I'm going to use the same information. Here I had two information. One of them was user one, the user ID, sorry, the other one was artist ID. Now what I will do, I will send events for user two, simulating that another user is listening to, for example, the fourth artist, Ellen Segara, couple of times. Should be fine. All right. In the meantime, when we wait for the index, event index to be processed, I'm gonna show you another aggregation request here, which is going to aggregate the same listen events with two dimensions. The first dimension is users here. I want to aggregate the events first of all by user with the user ID, and then all of the artists listened to by this user in another aggregated bucket, which is artist ID. If I run this, what I will see at the end, I will see the users. I have two users, user one, user two. User one's profile contains three artists with the number of times that user listens to these artists, but the user two profile contains only one artist, which is artist four, 10 times. All right. So what I will do now, I will go back to my client, switch the algorithm. I don't want the ranking based algorithm, but I want to use a user profile based algorithm. With this user one first, let's see user three, because user three does not have any profile in our system because this user has not listened to anything. So what it will get is typical Elasticsearch full text scoring results, 0.1 to 0.1, very close to each other. But if I go to user one, meaning that our first user is the one making this search request, I'm gonna get the similar listing here. You see Shakira, Selena, and then Sezen. Shakira, Selena, Sezen. Without changing anything, without changing any algorithm, any implementation, anything, but just the user ID who is making the request, I'm gonna see Helen, which I have not seen yet in the top results, because she is the one that this user likes, listens a lot, has profile in his or her history, listening history, so that this artist is promoted to this user. Basically, I think we have managed what we uh, wanted to achieve. I'm going to show you the details because it's not very easy to have all these things functioning. I just wanted to make the demo first, and then I'm going to go into details like I have 7 or 8 minutes, something like that. So user profile based boosting, to my understanding, is basically find a relationship between your user profiles and your content profiles. What I have done in the demo, for the sake of the demo, for simplicity, I have just used the artist IDs because I know which users listen to which artists, so I can keep the number of times a user listens to artist. I keep the relation with a user to artist with the IDs, but this is not always a good solution. It's not always easy because we have almost 1 million artists, like 20 million plus songs. So it's not easy to maintain an ID-based relationship. It's going to be costly, but it's very easy for the sake of the demo. So you need to find a relationship. Once you find the relationship between the user profiles and content profiles, you should maintain user profile index or indices. You can make your user profile also time-based in order to like follow the trend on the user's behavior as well. But I kept only one index here for the sake of the demo. User profiles should be updated, and then search rules should be changed, should be modified to include this relationship in terms of mathematical calculations. And then we will get the results that we saw in the demo. What helps us do so is this Elasticsearch query. Okay. It is a function score query that I should use. Function score queries work like this. First, execute the typical Elasticsearch query, the main query that will find the documents. This query might be any Elasticsearch query supported. Here I show you it could be a term query, it could be a match query, it could be phrase queries, anything, okay? Once the targeted documents are found with this query, these functions are applied. It's a set of, as you can see, it's a set of functions. You can provide as many functions as you want here, but this specific function is a script score function with this script. What it does is basically take the score calculated from the full text search, okay, but multiply this with some values, with some factors. If the document's artist ID is the one that our user is related to, okay? Here, to keep it short, simple, I put two examples, artist 1 and artist 2, A1 and A2, but artist 1 has 128 times ranking for this user, but artist 2 has only 16, all right? So this mathematical calculation, what it will do, it will take log of this number with base 2, basically, which makes 6 or 7 something. And then here, the log of 16 with base 2 is 4. So artist 1 is promoted more than the others, okay? Artist 1 is, even if Sezen Aksu ranking in the system is low, she is brought to the top. And then in the second comes artist 2. If I change the query here, make artist 4, I'm gonna see artist 4 in the second place. This is basically what you have to achieve. You have to find the formula based on your scenario. You have to come up with the formula with this mathematical representation of the relationship between users and the documents. The Spring version of this formula is in Elasticsearch service.java, which is basically creating an Elasticsearch REST high-level client search request object pointing to the content index, meaning that this query should be performed on this content index. And then what I'm doing is I'm basically converting this Elasticsearch query to Java. I need a function score. Here you will see somewhere, you will see the function score query builder. Here, function score query builder, which takes two arguments. The first one is the bool query builder. The second one is the filter functions, as can be seen here, a query and the functions. And boost mode, score mode, sum means that the score obtained from the query and the scores obtained from each of these functions will be summarized, will be added. You can use sum, you can use multiply. Let's see what you can use. Average, first, max, min, etc. But I like sum. Okay. Let's go to the bool query builder section. Here I represent the multi-match query builder, saying that this field is twice more important than this field, because if I find an exact match, I want to promote it. Instead of having an artist including the prefix of that specific match, these artists should be scored twice. This factor affects that. Operator is and, fuzziness is 0. I don't really like fuzziness, but fuzziness is also good. You may want to fix your users' typos, but if you do so, please pay attention to provide little boosting factor. Otherwise, corrected or broken contents might show up before the really relevant things. One last sentence. I'm just on time. My last minute is the conversion of this function script from this version to Java. It's the same thing. I'm going to provide the string math.max score times something. Something is a loop. Loop is working on the user profile, artist ranking sets. Please go into GitHub, download the project, have a look, and if you have any questions, feel free to ask me. Okay, what's next from here? As I said, you need to find enhanced full text capabilities. Definitely, I provide you simple things, and find the other ways of profiling content and users. These can be options. Scalable event processing, use Kafka, not like me doing demo version here. And also cluster configuration, high availability are main concerns. Thanks for watching and listening to me. I hope it was helpful. You find something useful for you to take away with you and use in your professional things. Let me see. This is my first. Okay, we have no questions. Okay,
Awesome.
cool.
Thank you so much. It was great. And now we can open it for questions, of course, if anyone wants to ask something.
All right. So if you have any questions, we have 15 minutes. I'm going to try to answer. Or if someone in the audience has the answer, help me.
We have already one question.
Where should I see it?
You can see it in, there's a Q&A app tab under, if you can see it. If not, I'll read it to you.
It's not yet there.
No, it's
so the question is,
it's in the chat part, I think.
It's in the chat part, sorry.
Chat, is it? Let me see.
In the chat, yes.
Okay, where is chat? Participant.
Should be under.
Maybe here, chat, yeah, here. Okay. Oh, okay.
The last one, can you see it?
To use params in plain script instead of passing variables like, yeah, obviously, yes, that's correct. You are right. This friend points to me that it's not always good to use hard-coded values. Instead, we should provide them as arguments, parameters. You are right. Let me see if I have it in my project. If I don't, I'm gonna do it. This is a very good comment.
I wanted to add maybe a pull request to your project.
Sorry? Yeah. Okay. I'm not gonna spend time. Cool. That I really appreciate it. Thank you very much.
But can you share the link, by the way, of the GitHub repository?
Repository, sure. The link is here. It's Gunayus. My GitHub name is Gunayus, and Elastic Workshop.
Okay, thank you.
Okay, Gunayus, Elastic Workshop. Thank you for the contribution. Let me see again the chat. If we have, if a user listen one, the correct, that's correct. That's what I said, that it's not the right way we should use. The ID-based relationship profiling is not good, because if we have 100 artists, it causes trouble. What I have done is this option. Let me close this participants part. Okay. I have done this artist clustering by collaborative filtering. I may find related artists. I can analyze the network, what is happening, who is listening to which artist, and the same artists are listening to other users. So these users listen to some other artists. So I can cluster these artists together. while doing the clustering, I bring the number of profiles to lower values, like at most 200 clusters, 500 clusters, 50 clusters, 1000 clusters. And out of these clusters, the number of clusters that a user has profile in his profile or her profile gets lower. So this is a very good point. That's why we shouldn't use ID-based profiling. We should use some other techniques. I'm looking for this one. This is more occurrent. Collaborative filtering is not also the perfect solution. Audio acoustics is the one we are looking now, because if we can detect the acoustics of our songs, we can profile our artists accordingly, and then we can profile our users also, like rock music listeners, classical music listeners, etc. Thank you for this comment, Christy. Do we have any questions? Yeah. How do you calculate the best score function for search in Turkcell? I think you mean this user profile based score function. We use both of them together, ranking and user profile based, and we use the collaborative filtering based artist clustering. If I may have answered the question. If we have a legacy old relational DB such as Oracle, how could we integrate some tables of DB to Elastic? Site, I think this is the outside of the scope of this session, but we can always discuss it together, okay? Promise that. Any other questions? Chats? I don't see. We still have some time. I think it was clear. Huh? Okay then. Dalia, can I finish it here?
Yes, of course.
Okay.
Thank you again for presenting. It was super clear and I really liked it. And thanks for everyone who joined to listen. We will edit the recording and upload it to YouTube, and I will send you the link.
Great.
So yeah, thank you again.
Perfect. Thank you very much.
Thanks everyone. Bye.
Bye-bye.